You are watching the 4.4 lesson video on transforming the exponential parent function. I'm hoping that this lesson is going to be a lot of review and pretty easy for us because we spent so much time in Unit 2 transforming all the functions, so moving them left, right, down, up, flipping. We're going to do the same thing here, only we're focusing just on the exponential function. And you will be happy to know that everything that you learned is going to basically connect to everything that we're going to do today. So without further ado, let's graph and label the exponential parent function, which is f of x is equal to 2 to the x. You might wonder, well, why is it not f of x is equal to 1 to the x? Well, if we had f of x is equal to 1 to the x, and I kept putting in different powers, 1 squared or 1 to the 10th power, or no matter what you put as the exponent, you will get an output of 1. So that's why we don't use our exponential parent function as 1 to the x. All right, let's generate the table of values. Some of you might be able to do this freehand because you're very good with your exponents. So if I want to create my table of values, I would get 2 to the 0 power is 1, 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8, and again, we're just multiplying by 2 as we continue to the right. So if we go to the left, we're going to divide by 2. So 1 divided by 2 is a half, then 0.25, so a quarter, and so on. All right, now let's plot them. Remember, our y-intercept is not at 0. In fact, our graph never actually touches 0. So here we are plotting all the points, and on the left of the axis, my points get closer and closer and closer to the x-axis, but never actually touch. And we know this because no matter what, if we keep dividing something by 2, the number will get smaller and smaller and smaller, but will never actually ever hit 0. Now we can use our graph and table to evaluate. Remember, anytime you have a number inside the parentheses, that's our input. So you put it in the parentheses, it's our input. It's our x value. So our x value of 0 gives us a y value of 1. Our x value of 1 gives us a y value of 2. Our x value of negative 3 gives us a y value of 0.125. D says find x when y, or our output, is equal to 1. So where is our output equal to 1? When x is 0. And how about our output of negative 8? What is our input, or our x value? That happens to be 3. All right, now we need to discuss the key characteristics of this graph, the domain and range and so on and so forth. Let's take care of the intercepts first. So I'm going to skip down to H. We can see from our table up above and from our graph that our y-intercept is happening right here. And I'm going to write this as a coordinate, so 0, 1. How about x-intercepts? Is there an x-intercept? None. It will never, ever touch. So there is no x-intercepts. An asymptote, something that we haven't really talked about before. It almost sounds like I'm swearing, but I'm not. It's a real word. We consider asymptotes to be something that our function gets really, really, really close to, but never actually touches, which happens to be this x-axis here. And I'm going to draw in as a dashed line because it's not something that actually exists, but it is something that is there kind of just bounding our function and saying you cannot go below the x-axis. And the equation of the x-axis, believe it or not, is when y is equal to 0, because I'm not going up and I'm not going down, I'm staying right here. And it is now asking us to, well, I guess we should rewind and go back to the domain and range. Well, where is the function on our x values? Well, it starts where? Let's go all the way to the left. Oh my goodness, oh my goodness, oh my goodness. There's an arrow on the end which indicates that we're starting at negative infinity and we're continuing. Okay, let's go from left to right now, up, 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 up. And since we're going up and to the right, positive infinity. Our range is a little bit different. Some people prefer to write this as an inequality. Since we already used our interval notation in part F, let's go ahead and use inequality notation for our range. So what do you notice about the y values? Well, they are always going to be above this red line here, asymptote. So why, or how could we say that? Well, we could say that y is always bigger than 0. Notice how I didn't say bigger than or equal to 0 because it will never actually touch that dashed red line. And if you notice our function, it follows the same pattern, yet it just grows at a faster rate as we get into the positive numbers, but regardless, our function is always going to be increasing, because if I go from left to right, if I put a man on it, he would go up the line or up the function. We're just listing our entire domain from negative infinity all the way to positive infinity. One thing that we should know is that the graphs of all exponential functions, they're actually transformations of the parent function. All right, let's move on. So in part 2, we have 3 functions, or question 2, and they want us to write the equation of the function below, which is a transformation of the parent function. And if you notice, they've actually graphed the parent function for us to help us see. If they hadn't done this, we should do it ourselves. But yay, we don't have to. What do you notice happened between f of x and g of x? Well, the first thing I like to do is compare my points. A lot of times the y-intercept is one of the most helpful points because it helps us to see what has happened to our function. So our function went down 1, 2, 3, 4. Well, we always start with our parent function, right? 2 to the x. How would I show a shift of down 4? Well, a shift of down 4 would be subtracting 4 on the outside of the function, similar to what we did back in Unit 2. All right, let's move on to h of x. We need to decide what has happened between here and our new function, h of x. And it looks like we went to the right 1, 2, 3 spaces. I always like to write in words what's happening because it helps me to see the connection. So again, we start with our parent function, 2 to the x, and a shift of right. Remember, the left and right, the signs are always the opposite of what you think. So typically we would say to the right 3 would be plus 3, but in this case it's going to be minus 3, and this is inside the parentheses or up in the exponent. That's the difference now, where we might not have used we might have used parentheses in the past. Here we are not going to do that. All right, j of x, lastly, what has happened? Well, some of you might say, oh, it's a shift of down 1, 2, but in actuality, it looks like there was a flip, a reflection over the x-axis. Okay, so we're flipping over the x-axis, which to me means that my entire parent function of 2 to the x is just now negative. Moving on to page 3, we need to identify the transformation and write in words what has happened and graph and label. Let's take a minute and talk about what type of transformations actually happened from A, B, and C. One thing that you should obviously know is that the parent function, and let's write it up at the top, the parent function is f of x is equal to 2 to the x. If you ever get stuck, you can always use your technology to help you to maybe make it look more like what we did in example number 2. But in A, we see a 4 on the outside, which means it's a shift of 4 up, or the parent was moved up 4. B, we have a minus 5 up in the power, which means it's a shift of left or right. and it always does the opposite of what we think. So this would be right 5, and C has a negative out in front, so this would reflect or flip over the x-axis. All right, now what I would like to do first is just plot the parent function. It helps me to just see what's going on, and it helps me to also transform it because I now have some points to work with, even though this one's off a little bit. Okay, so here's my parent. Let's label it. Some of you might just want to say it's y, or f of x is equal to 2 to the x power. All right, let's graph A. I'm going to do A in green. So up 4. So take every single point and move it up 4 spaces. And will we be able to get this one? Yes, but it looks like our graph now has an asymptote at x is equal to 4 now, where it used to, or sorry, y is equal to 4, where it used to be y is equal to 0. So you can see that the asymptote actually follows our shift as well. All right, B, let's move it to the right, or move the parent function to the right 5. I'll do this in red. So go back to my purple function, and we're just going to move every single one of our points to the right 5. Notice how our asymptote didn't change here. We're still seeing that asymptote happening at y equals 0, or the x-axis. And one thing I'm just realizing, I didn't label, so let's go ahead and do that. This is b of x, and this was a of x. And lastly, let's graph c of x, or part C, and we're reflecting our purple function over the x-axis. So I'm taking all of my points and I'm just flipping them downward. My asymptote happens to fall in the same place, except now our function is falling underneath that asymptote. Okay, let's take a look now at 4. So number 4 says, identify the transformation, and notice how we are now looking at it in function notation, but we're still transforming our parent function. So we're still transforming f of x is equal to 2 to the x. All right, and they want us to show a table of values. So technology might become very helpful with this question. All right, A, x plus 4 is inside the parentheses, which means that it is a shift of left 4. B would be a shift of down 5, and C would be a shift of 7 to the right. Okay, now what I find to be really helpful is once I've converted or translated and read my function notation, I actually like to write out the function d of x using the parent function. So left 4 would make it look like 2 to the x plus 4 power. And down 5 for e of x, that would look like 2 to the x minus 5 on the outside. And c, which is m of x, would equal 2 to the x power, but since it's shifting to the right 7, that would become, not plus 7, minus 7. Okay, I would like for you right now to pause the video and complete the table of values for these 3 functions. You can go ahead and use your technology. Hopefully you're using your Nspire. If not, I believe that you can get some of the points from the Desmos calculator. And if all else fails, you can just substitute and simplify. Okay, so here are the 3 tables of values filled in. Because I have already graphed these all on my calculator, I am not going to have you graph them here on the graph. So you can just cross that off. We'll leave that step off. I think that sometimes the technology is a little bit more powerful, but at the same point in time, we should know how to plot points by now. Okay, last but not least, let's take a look at 5. So 5 says write the equation of an exponential parent function that has been transformed the following ways. Okay, so again, we are going back to our parent function y is equal to 2 to the x. So what I think that we just need to do here is write out the parent function in each, but because of all the changes, we are going to have to modify it a little bit. And I'm going to do all of my modifications. Let's do them in purple. So 7 to the left, well, that means we are going to have a plus 7 up in our exponent, and 4 up would mean plus 4 on the outside of the function. And if you're not sure, you could just simply graph this and see that the function indeed moves 7 to the left and 4 up. This would be an awesome way to check. Maybe we'll do that at the end. Okay, 3 to the right, well, that would be minus 3 in the exponent. 2 down would be on the outside, minus 2. Reflected over the x-axis, negative, and moved up 6, so plus 6. All right, lastly, let's go ahead and show the checks on our calculator. Okay, so here I have my part A, 7 to the left and 4 up. We can see that it has taken our parent function that's usually here and moved it 7 to the left and 4 up. Next, we have 3 to the right, so we've moved 3 to the right and 2 down to see our new orange function for part B. And lastly, part C means we flipped it and moved our function up 6 spaces.